Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about sound waves. Okay, so what exactly are sound waves? Well, let's look at this diagram here. This is a little person who's trying to speak and is trying to pass the information from the person to the human ear. Right, so what's going to happen to the air particles? The air particles, you can see in blue, those are the air particles. They're going to start to be compressed into certain regions. So we get a compression of air particles here, and maybe we get a compression of air particles over here. Loads of them start to cluster up, the rest of them spread out. Right, what type of wave does this remind you of? Is it transverse or longitudinal? Well, we can see that there are compressions, and compressions are a property of longitudinal waves. So these are compressions, and they are it's a property of longitudinal waves. So we've got the first point here. So sound waves, they are longitudinal waves, and they need a medium for them to travel. So it's traveling through the air right now. It may also travel through solids. They may also travel through liquids. So sound waves always require a medium to travel. So sound waves, they are longitudinal and they require a medium to travel. They require a medium to travel. Nice. Just like water, solids, yeah, all of them, totally fine. So, what are sound waves? They are longitudinal waves and they require a medium for them to travel. And next thing we're going to do is the bell in the jar experiment. This is a classic science experiment. We're just going to discuss the experiment and the outcome. So we have a clock inside a jar, and the jar is filled with air. If the alarm clock goes off, what's going to happen is the air particles will transmit that sound to the jar, and that will be able to radiate outwards if we're on the outside. So if I'm here, I can actually hear it. Yay, we can hear it. So let's put that down. I can hear it. So why? Make sure you understand the reason why. It's because the sound can travel through the air and hit the jar and then travel towards us through the air. But what happens now if I have the bell in the jar but I suction out the air particles? So right now I've removed the air particles from inside the jar. Can I still hear the bell? That is the question. Can we still hear the bell? Right, just think about it. Is there a medium for the sound to travel within the jar? No. So they can't travel through the air inside the jar. So the answer is no, as there isn't any air for the sound to be transferred. It's a great experiment, guys, so you can actually hear it if you do this in class. And this also gives rise to the phrase, in space no one can hear you scream. The reason why is because in space there are no particles, therefore sound cannot be transferred. Nice. Okay, right. What about if I asked you to work out the speed of sound? We can look at the following. So, let's say we want to look at an experiment to calculate the speed of sound using echoes. So there's me, and I've got two bricks. Not two bricks, two pieces of wood. If I clap them together, a sound wave will be released, hits the wall, and travel back again. Yeah? Let's say it took the time for that to occur, the sound wave to go there and come back. That is the time of the echo. Let's say it takes 0.5 seconds to do this. The question is, what is the speed of sound? How can I calculate the speed of sound? We can calculate the speed of sound by using speed is equal to distance divided by time. What is the distance that the sound has travelled? Is it 83 meters? No. The reason why is because I'm going there and back again. So therefore the distance is going to be 83 meters multiplied by 2 because I'm going there and back. So speed is equal to 83 times by 2. Yeah, and the time, let's say it took 0.5 seconds there. Here we go. So plug it into a calculator if you want. You know, if you can do the maths in your head, totally cool. 83 times by 2 divided by 0.5. Bang, I've got the speed of the wave is equal to 332 meters per second. And roughly, guys, if you were to, on average, the quoted value is 330 meters per second. You can memorize that, guys, because the speed of sound in air will always roughly be around that value. So the speed of sound in air is going to be 330 meters per second. And now you have a practical setup for you to do that calculation. Good stuff. Right, let's test our understanding. Well, I know, before that, let's look at an equation. So in your GCSE book, you may see the following equation, and you might think, where on earth does this come from? This is exactly the same as this problem here. Just exactly the same. But make sure you understand what the variables stand for. So this one is going to be displacement. This one is going to be the velocity of the wave, which is like the speed of the wave. This one is the echo time. So if you want to work out the distance, you'd have to do half times by the velocity times by the time. Why? Because the time was to go there and back. That's why I have to put the half in over here. So the half is needed. The reason why is because it's going there and back. I must divide by 2. So that is the same formula. Make sure you're familiar with it. You don't have to use this, guys. You can use, if you can spot it, that you must divide it by 2, that's totally fine. That's all good. Right, next of all, let's go. Test your understanding. Right, so we have the following question. Kevin is standing at the beach in front of a big cliff. He claps his hands and hears an echo after 1.5 seconds. How far away is the cliff? So what we're going to do right now is, so he claps his hand, it takes 1.5 seconds for the echo to come back, and the speed of sound is 340. How far away is the cliff? They're basically asking you for this distance. What is this distance? What is this distance? What is this distance? Alright, so we can work out the distance. We know that, so distance is equal to speed times by time. So the speed is going to be, look, have they given us the speed? 330 meters per second times by the time taken to go there and back is 1.5 seconds. So we've got 330 times by 1.5. It's going to be, so the distance is going to be, there we go, distance is going to be 495 meters. Is that the answer? Is that the actual distance, or is that the total distance? That is the total distance because we've worked out the time going there and back again, so this is the total distance. So to work out the actual distance to the actual thing, all we've got to do is divide it by 2. So this divided by 2 is going to be the distance, so 247.5 meters is the answer. So I need to divide by 2 as we are going there and back. Yeah? Make sure we understand that, yes? So I worked out the distance, the total distance going there and back again. So, and I have to divide that by 2 because I just want the distance to the cliff. Easy stuff. Next of all, let's scroll down for the actual summary. So here's a summary for this unit. Finally, it's come up. My screen is a bit frozen. So, summary. Number 1, sound waves are longitudinal waves and they require a medium to travel. Sound waves are caused by the vibration of air particles. The speed of sound is roughly 330 meters per second. We can use the following equation to calculate distance when using echoes. It's going to be S is equal to a half V times by T. And that's it, guys. Good stuff. I shall see you next time. Ciao, ciao.